In ancient Greece, there was a math riddle called the Race of Hercules that went like this. Imagine you have Hercules, who apparently has a very small head, and he is running a race from point A to point B. And in his first step, he covers half of the distance. And then in his second step, he covers again half the distance. His third, again half the distance. And in his fourth, again half of the remaining distance. Does he ever finish the race? In ancient Greece, this was used as one of many examples of basically hubris, of Hercules thinking he could finish the race. But the mathematics part of it is honestly much more interesting. Because basically what's going on here is that if this distance is 1, then this is 1/2, 1/4, 1/8, 1/16. This would be 1/32, and so on. Each time you are adding half a distance, and this works out to basically, after n steps, so this is first step, you are adding 1 over two to the power of n steps. First step, 1/2, 2 to the power of 1 is 1. Second, 1/4, 2 to the power of 2 is 2, 2 to the power of 3 is 8, so on. And so this is 1/2 plus 1/4 plus 1/8, and so on. Now, like I've already said, the moral riddle answer is that no, Hercules will never finish the race, but the mathematical answer is that yes, he will finish the race if he manages to take an infinite number of steps. Because eventually, after having taken an infinite number of steps, the amount remaining will be 2 to the power of infinity, so 0. And his next step will be 2 to the power of infinity plus 1, which is also 0. So after an infinite number of steps, he can finish the race. Now, while this bit of mathematics here is technically not correct, that's mainly just because I couldn't be bothered to write out the entire thing, which would be the limit of 1/2 to the power of n as n approaches to infinity. That's the proper way to write this, but I can't be bothered to do that because I am trying to draw with a mouse right now. The modern equivalent of this, however, is not so simple. The modern version of this riddle is if you have the square root of 2 times 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 the square root, and so on. This goes on forever. What is this infinite equation equal to? This is an example of a sequence, which is basically just a list of terms or equations. So say you have a sequence where the first term is the square root of 2, and the second term is the square root of 2 times the square root of 2. Is the second term. You can probably see where this is going. If you have some term t of n, so this would be term 1, so t1, this is term 2, so t2, you have term, and then you have term n. This is basically the square root of 2 times the previous term, sort of square root of 2 times then containing the previous term. And if you have t of infinity, well, that's what this is. Now that I have described what this infinitely long equation actually is, it is time to figure out what it is equal to, since we do not currently know. In order to do that, we need to rewrite it a bit. Since square roots at least when all the terms are multiplied, can be broken apart. This can be written as the square root of 2 times the square root of the square root of 2 times the square root of the square root of 2, and so on. Now, since a square root is just something to the power of 1/2, and powers multiplied together, this can be rewritten as 2 to the power of 1/2 times 2 to the power of 1/4 times 2 to the power of 1/8. Now, when multiplying the same base to a bunch of different exponents, you just add them all together. So this, at least, equals 2 to the power of 7/8. And if I wrote out a fourth term of the sequence, it would be 2 to the power of 15/16. With this, we can now describe the equation as a whole, because in this case, with 3 terms written out, it is 2 to the power of 8, which is 2 cubed, or 2 to the power of 3, dividing itself minus 1. So, for n terms, in this case, 1, 2, 3, 4, n square roots, ... The equation for it in total is just 2 to the power of n dividing 2 to the power of n minus 1. Now, using the same lazily and wrongly plugging in infinity, but you still technically get the right answer in this case, 2 to the power of infinity is infinity, and infinity minus 1 is still infinity. So infinity over infinity, once again, wrong, but in this case it works, is 1. So if n equals infinity, this just equals 2. So this entire thing of infinitely nested square roots of 2 just equals 2.